Hello, everyone. Welcome back to another new episode of the LLM News, where I cover the most interesting and exciting developments around AI and the world of large language models. First up, we have this big announcement from Evolutionary Scale, and they are announcing this new model called ESM3, which is a new LLM based biological model that generates a new green fluorescent protein. To understand how groundbreaking and impressive this announcement is, here's a quote from the announcement that they're using an analysis similar to one might perform on a new protein found in the natural world. They estimate that ESMGFP, which is the green fluorescent protein that they discovered, represents an equivalent of over 500 million years of natural evolution performed by an evolutionary simulator. So essentially, they are considering that this is a really powerful evolutionary simulator and can be used to understand basically the nature of proteins. So this is an impressive work. I have also done a detailed summary of this on my YouTube. So if you're interested in that, I'll provide the link in the description. Next up, we have this announcement from Logan Kilpatrick. He's now working at Google, and there are a couple of news for Google AI developers. So these are developments for the Gemini models. And first, Gemini 1.5 Pro 2 million context is available to all. So previously we had the 1 million context, and now we have 2 million context, which will support obviously more tokens. And so you can add a lot more tokens in that context window when you're doing that input. And so you should be able to now put like PDF documents and really long files where you can do large scale analysis with these models. Now, I've only experimented with the 1 million context. I am also very curious to see how people use the 2 million context, but I think also this unlocks more capabilities and probably unlocks more use cases or unique use cases like some type of agentic workflows or even some agentic RAG systems as well. It was announced also that there is availability of code execution, right? This is now available with Gemini 1.5 as well. So the code execution is a bit like what ChatGPT offers with the code interpreter, right? It's a very similar tool. In fact, we did a video of this as well in my YouTube, and I'll provide a link in the description where I show you what this particular code execution tool does. But essentially, you can ask it to generate code first, right? It would generate code. It would use a sort of interpreter. It would run that code, right? If it's an analysis or whatever, and then it will return to you some output, right? So it does execute code, and so that's really useful when you need to use some external interpreter to do potentially some analysis, some quick analysis, right, to generate code, maybe do some math operations as well. Could be useful to enhance the performance of large language models. So I think this was something that was missing as a feature, and I'm excited that this was added as part of the APIs. The next one is Gemini 1.5 Flash. Text tuning has started gradually rolling out. So this is about the Flash models. We know that these models are quite fast and very performant as well. And they're basically an alternative to 1.5 Pro. But Gemma 2 is now available in AI Studio. Gemma 2 was also announced here. Now, Gemma 2 is at 27 billion parameter model. Excited to see a roughly 30 billion parameter open language model, because I think the 30 billion open language model is a lot more accessible for researchers and also developers that may want to tune these models, right, and need something that is more cost efficient or maybe more affordable. I think this type of models have a lot of potential. And something that they mentioned also that is this 27B seems to outperform models twice its size as well. So they're doing comparisons with like Llama 370B and then Grok 1 as well, 340 billion parameter. So the results are pretty remarkable, and they only test on reasoning general benchmarks at MMLU, Big Bench Hard as well, HellaSwag, Math, which is the common math benchmarks. You can see the performance of Gemma 2 here. And then there is also code generation evaluation. I got a lot of questions about the code generation capabilities. From what I can tell, it definitely can generate very basic code like other open models. Now, if you're interested to use like an open model for code generation, I think you may want to check out CodeStrel and DeepSeek Coder version 2, the one that was recently released. Those are I think more custom models for code generation. So if you're interested in that, do check those out. But I do believe like the community will probably do comparisons with these models as well. But this is not a dedicated model, just to be clear about code generation. It's a general purpose model, and it was trained obviously on massive data related to code, math, reasoning, and all of it combined, right? So I think we still have to take that into consideration. It's not a dedicated model for code. Next up, we have this announcement from ChatGPT. Now they're announcing the availability of ChatGPT on desktop, and this is only available for macOS. It has a bunch of really cool things that you can do. You can take screenshots, you can pass it to it. It does have a lot of really nice integration as well with macOS, right? And if you're using an IDE, for instance, you can take a screenshot, right? You can use that on the macOS app, and you can interact with it, ask a question about it, right? Like in this case, you're saying that it's interacting with the system. This is too slow. I'm excited about the accessibility of this because obviously you can always use it on the browser, but nothing compares with when you have that accessible on your machine and you can just run the app and have a quick access to tools like this. So there's a lot that it can unlock, and you can also use these voice features apparently. There was another interesting announcement from OpenAI this week as well. So they announced this model called CriticGPT. This is not a new idea. I do believe that a lot of companies are working on creating like LLM-based verifiers and moderation tools. And one of those type of models that is of high interest is to generate a model that can critique the outputs, right? The quality of the outputs of another model. In this case, they're critiquing ChatGPT responses to help human trainers spot mistakes during RLHF. So RLHF, reinforcement learning from human feedback, is what is used to do alignment with these models, right? So that it fits human preferences. So this is why we can use ChatGPT to do all sorts of tasks, but it's not perfect, right? And usually it involves human trainers. So how can we help these human annotators, right? These folks that help train these models, especially on tasks where it's a bit more complex, right? So if you're maybe assessing something that generates a short response, like a text summarization of an article, maybe that's not that difficult to assess and annotate. But then if you have a longer article that's generated, or maybe longer code or something like that, it's harder to assess that, right? So we could potentially use another model to help critique and to take that critique as humans to be able to do better assessment of the outputs of these models. So that's basically the idea that they're proposing here. They are also publishing a paper for this, which is also very cool because obviously this helps a lot with people that are working with language models, not just their company. And also like when you use these OpenAI models, right, it's very helpful to understand how to build moderation layers and these verification layers. We do a lot of verification systems to ensure that these models don't hallucinate and these additional steps that you would need for like generating safety outputs. So if they can build that right in, or they can propose a model or some kind of solution later on that is backed by this CriticGPT model, I think it'll be really interesting. Right now, they are using it mostly for their human trainers, but I think this has a lot of potential to become some sort of service as well, which is something that'll be really cool to have as a developer. They mention here, I'm just going to read the first few sentences here. So they have trained a model based on GPT-4. This is the model that they're using as base model. I'll create GPT to catch errors in ChatGPT's code output, right? So this is mostly about code, but I think this can generalize as well. We found that when people get help from CriticGPT to review ChatGPT code, they outperform those without help 60% of the time. We're beginning to work to integrate CriticGPT-like models into our RLHF labeling pipeline, providing our trainers, right? This is like human annotators with explicit AI assistance. So again, this is about creating a system that can assist those human trainers. This is a step towards being able to evaluate outputs from advanced AI systems that can be difficult for people to rate without better tooling. So that's the idea. I'm not going to go through all the details, like I said, but I do show some interesting results, right? Obviously, their CriticGPT model seems to be outperforming even using human plus CriticGPT. But the point is that, it's better for maybe a human trainer to to have a system that can help them around this. And you can see it in the result here, how it boosts the performance of when a human is using a human annotator trainer is using something like CriticGPT, right? And so that's kind of the idea here. And they show the methodology as well, how they collect the data, right? What's the data collection process, which is really important. But they also mentioned too that this is prone to mistakes as well, right? Because you could have this model generating stuff that looks real, right? That looks like it's gonna run, and in fact it doesn't. And that's usually happens with more complex tasks where it's subtle. Maybe a human trainer doesn't have the right expertise or the right level of understanding of that particular task. It only gets harder for annotators because these models, right, they're creating more subtle and more subtle outputs, right? And outputs that look, again, they can fool you because they look like they're outputs that look correct, but might indeed have some problems or have some bugs in this case with code. Next up, we have the LLM Compiler from Meta. Meta AI announced a family of models built on Meta Code Llama. So this one is built on Code Llama as well, with additional code optimization and compiler capabilities. These models can emulate the compiler, predict optimal passes for code size, and disassemble code. They can be fine-tuned for new optimizations and compiler tasks. Now, this is an exciting area as well because we do have code generation, right? Code generation is focusing on these programming languages, high-level programming languages like Python, potentially like Ruby or JavaScript, Java, and so on. But then also we need tools that could potentially generate code, maybe doing some disassembling of code. If we're going to use LLMs to do more complex things with the operating system, for instance, which there has been a lot of discussion around that, we need tools like this, right? We need tools that have better understanding of the code at that level. And so I think it's an important area to also be focusing on. They achieve state-of-the-art results on code size optimization and disassembly, as I was saying. This work shows that AI is learning to optimize code and can assist compiler experts in identifying opportunities to apply optimization. Yes, it's for compiler experts, an assistant tool as well, but it also could be used like in agentic workflows where you need to maybe optimize something at the low level. I think just like with code generation, this can be really useful to build more general purpose assistants as well. And they're releasing these models under a permissive license for both research and commercial use. They also have a paper, so click on the link if you are interested in the paper. In the next couple of posts, I'm going to talk about some interesting papers that I came across. The first one is this GraphReader. I'm seeing a lot of research papers proposing the use of like some external structure to guide the model to do better reasoning or to better perform on specific tasks. So I've covered a few of them that are using like tree structures. There's a couple of them. This one is proposing a graph-based agent system to enhance long context abilities of LLM. So this is more about long context abilities, but it's also an agent system as well. And is using graph structure, which is very similar to tree structure. And again, the concept here is that you're using this external information that you have put together to better guide the model, which is in this case to enhance long context capabilities. It says it first structures long text into a graph, right? Elements and facts, and employs an agent to explore that graph when it's doing inferencing using predefined functions guided by a step-by-step rational plan. The agent accesses coarse graph components and detailed text, takes notes, and reflects until enough information has been gathered to generate an answer. And this approach helps to effectively and reliably generate answers to questions, claims to consistently outperform GPT-4 128K. So this is the 128 context window across context lengths from 16K to 256K. So they get very consistent performance. And as I mentioned here, right, you can never sleep on the power of graph or tree structures, which in this case helps to capture long-range dependencies and multi-hop relationships within long text. But I'm noticing that other researchers are using this for like enhancing reasoning as well. And that makes a lot of sense because standing of that structure, explicitly doing that and representing that information that way, I think is really helpful for LLMs. And has to do again with structuring inputs. Same way how structuring outputs is very beneficial for LLMs, structuring the input is also very beneficial. I've spoken about this on multiple occasions. Actually, my recent LLM news episodes, I talk about this in my course as well. Better understanding of the data that you're passing in helps the model to get better results. Next up, this paper from Xiong et al. Improving retrieval in LLMs by fine-tuning on synthetic data. Now, I've saw a couple of papers that are leveraging synthetic data. In fact, the first paper that I highlighted with the ESM3 biological model is using synthetic data. So there is use of synthetic data everywhere pretty much. And that's an exciting, I think, development in the world of LLMs, because so far synthetic data has been mostly used to generate this toy synthetic data to use to where you can fine tune a model and so on. But now you can use this data to build models that better understand structure, for instance, or output structured data. Right, you can use it for fine-tuning models as well. I've seen a couple of papers talking about that, and it started to become this really reliable way of improving these systems. And in this case, is to improve the retrieval capabilities in LLMs by fine-tuning on this synthetic data. What's interesting about this paper is that they use very simple fine-tuning data set, right, the synthetic data set that they generated. And you can see here an example of how it looks. It's basically a numerical dictionary key value retrieval task. So they have like 350 samples of those, right? Dictionary one, you can see the different examples here. And this results in improving many things, right? So they mentioned that they find that this approach mitigates the loss in the middle phenomena and improves performance on both information retrieval on long context reasoning as well. Traditionally, how this would be done, let's say you wanted to improve math reasoning capabilities, you will collect a math reasoning data set and you will tune that model to make it better at math reasoning benchmarks or tasks. But this one, it's not doing that. It's basically trying to get the model to be able to perform this task really well. And by fine-tuning it on that, it's able to unlock these capabilities, which is very surprising. And an interesting quote from a paper here. Finally, another advantage of our proposed data set is that it contains no factual information. This is what I was saying, right? And it seems that this type of data is easier to generate, and you can do it in a synthetic way, right? And so that's kind of the interesting part of this paper. As it was recently discovered by Gemma et al., fine-tuning on previously unseen knowledge may encourage hallucinations. This is something we have spoken a lot about in our recent episodes, that when you fine-tune a model, there's all these benefits that you get, but there's also all of these kind of problems that you will face, right? Like hallucination, if you have a lot of new knowledge that you're introducing to the system weights, and you're tuning the model on that, it may lead to a lot of hallucination problems, which does happen a lot with fine tuning. And so, how to control for that? There's also the problem of catastrophic forgetting. So, when you're tuning these models, sometimes the model forgets maybe knowledge that it already had. And so, that's really problematic because that's not what you want, right? You want the model to be able to learn what you're training it on, fine-tuning it on, without forgetting what it has been pre-trained on. So thus fine-tuning on our key value dataset improves LLM retrieval and reasoning without suffering from such unwanted characteristics. Again, because you can see how this dataset looks. It's really interesting that they unlock these capabilities. And the question is, like, are there ways on how we can improve other capabilities of these models, like let's say code generation or like chain of thought generation or something like that, without having to do a lot of effort, or we can do it in a synthetic way. This seems to be a very simple way of collecting this type of data set. Next up, we have this paper, LongRAG, Enhancing Retrieval Augmented Generation with Long Context LLMs. The idea of this paper is proposing to use these ideas together, right? Like use long context LLMs with these RAG systems. Okay, maybe long context LLMs are so good they're going to replace these retrieval augmented generation systems. But I like actually to think how we can combine these technologies to even get better performance. And as I mentioned before, usually it's a hybrid of ideas that's going to lead to better performance. You can start with a RAG system, but it could end up to be the case that with your use case, it's beneficial to have long context LLM because a long context LLM probably has better capabilities to maybe analyze longer text. Like if you have a use case where you're retrieving longer and longer text, long context LLM might be helpful for you. And this is what they show in this paper. And long context LLMs are not perfect, obviously. So also long context LLMs can benefit from a retrieval augmented generation system as well. This is what they discuss in the paper. Now, an interesting quote from the paper here: the improvement in retriever can significantly benefit the reader model. By exploiting the long context understanding ability of GPT-4o, LongRAG can achieve an EM of 62% on an NQ. NQ is a benchmark, and 64% on hotpot QA. These results could be comparable to the strongest fine-tuned RAG models like Atlas and MDR. So do check it out. I think this is really an interesting direction as well, like combining all of these ideas as opposed to throwing them away. This is how I like to think about LLMs, right? How do we combine things like fine-tuned models with general purpose models, taking some type of external structure and combining that with a language model, in this case, a long context LLM with a RAG system. I think that would generally lead to a better performance. Next up, we have this course, and I really like this course. This course is talking on really important topics, right? As we talk about fine tuning of LLMs, most of these large language models, right, they do require a lot of computational resources. So it's really good to be familiar with different algorithms and methods that enable efficient machine learning systems. And so, like how to do compression, pruning, quantization, neural architecture search, distributed training, data model parallelism, on device fine tuning, all these important topics, right? How to do better fine tuning, more efficient fine tuning as well, how to collect data, how to do generate synthetic data, as we discussed in the previous paper. All of that is covered in this MIT course. So I wanted to call it out. Not every language model out there will be accessible and affordable to everyone. And so being familiar with techniques like this is really important for an AI engineer that maybe wants to build a product on a smaller language model, maybe a model of 30B, for instance, the size of 30B, where you want to fine tune it on maybe something like code generation, but you don't have the resources, right? And so maybe you want to compress those models or quantize those models as well. Lastly, we have this Perplexica. Now, this has been trending for a bit now, and I just wanted to call it out. No, you might be familiar already with Perplexity at AI, right? So it's like a AI-powered search engine. It gives you answers instead of links. It has been considered to be like an alternative for Google, right, where you can search for information and so on. So I use it as well personally, and I use it for specific tasks. I still use Google a lot, but I use it for specific tasks when I want to ask something very, very specific that I know a search engine probably wouldn't give me. And so they are an important, I think, an interesting solution for you to get answers and more detailed answers on questions that you may have. And there's also an open source version of this. This one is an MIT license, and it's called Perplexica. And it seems to imitate what Perplexity looks like, right? The interface at least looks very similar from what I can tell. And so do check it out. It's an open source project again. Maybe you can modify how it looks, right? The services it uses, how it does the answer generation, how it renders, at least for me, it's very interesting how it renders the citations. The citations are really key for the experience that you get with tools like Perplexity, in my opinion. And so I'm excited to see that there is an open source project. I'll be looking into this a bit more closely and potentially do a separate video on this. So that will be it for this episode of LLM News. So thanks for tuning in, and I'll be seeing you in the next one.